Welcome to the Eternal Bright Light channel. This is the first video of the Technological Blueprint series, where we are going to discuss on science and technology. Let's begin by discussing one of the core concepts of modern science and technology. Today, we will discuss about the atomic theory, and explain it in the simplest way possible, so that people of all ages can easily understand this vital concept. Have you ever let a glass of water, or a cup of tea, accidentally slip from your hand? Well, it must have felt bad, right? To see the glass or the cup strike the surface of the floor, and get shattered into small pieces? But, instead of cleaning the mess, have you tried to break them further into even smaller pieces? Or, in other words, did you ever think, how far can you break a piece of matter? It is this simple thought, which acted as a catalyst, to give birth to the atomic theory. To trace the origin of the atomic theory, we have to go as far as to the ancient cultures of Greece and India. In around 400 BC, Democritus from ancient Greece called these small particles of matter as atoms, which means uncuttable. He believed, if you keep cutting or dividing a piece of matter, you will reach a state when you can't divide it anymore. Although, he didn't have any evidence to back up his claim at that time. So, the idea was dismissed by the majority. Now, fast forward to around 1700 AD, Lavoisier and his wife showed through experiments that water can be broken down to two gases, hydrogen and oxygen. But they could not break these gases further. They concluded that these gases to be elements, that is, they must be the primary constituents of matter. Similarly, since then, scientists have found many such elements, which make up the modern periodic table, which consists of more than hundreds of such unique elements today. Then, in the early 19th century, a British chemist called John Dalton discovered that these primary constituent of matter, the elements, can be further divided into even smaller particles. He named them atoms. He found out that it is these atoms which makes every element different, and with unique characteristics, because the structure of atoms are different in each elements. Later, Albert Einstein also proved the existence of these atoms by equations. Everyone was more or less convinced at that time that atoms are the smallest and indivisible particles of matter. But still, this atomic theory wasn't complete. There were many things which could not be explained by this model. So, scientists started to realize there must be something more fundamental which constitutes an atom. That is, atoms must be divisible into further smaller particles, called the subatomic particles. Several theories were put forward, but still, none could experimentally prove the existence of the subatomic particles. Then finally, three scientists experimentally proved the existence of three such subatomic particles: electron, proton and neutron. In 1897, J.J. Thomson proved the existence of electron. In 1920, Ernest Rutherford proved the existence of proton. And in 1932, James Chadwick proved the existence of neutron. Many other subatomic particles have since been discovered, but today we will focus only on these three subatomic particles. Based on the existence of the subatomic particles, many atomic models were put forward by various scientists. But today we will discuss in short about the Bohr's atomic model, presented by scientist Niels Bohr. This model is also called the Rutherford-Bohr model, as both scientists made significant contributions towards its development. This model states that the proton particles, which are positively charged, remains together with the neutron particles, which are chargeless, at the center of the atom, in the form of a nucleus. And the electron particles, which are negatively charged, keeps revolving around this nucleus. This model is similar to the planetary model, where the planets revolve around the sun. Every atom has an equal number of electrons and protons, but the number of neutrons may vary. If any one of electron or proton exceeds in number than the other, then the balance will be lost, and the atom becomes either a positively or negatively charged ion. But you might think, if electrons are continuously revolving, then it should slowly lose its energy and go crashing into the nucleus. But of course, that does not happen in reality, otherwise the universe would not exist at all. Well, that's because the electrons revolve around the nucleus in fixed path or orbital called the shell or energy level. So, when the electrons revolve, they do not radiate or lose any energy, therefore it helps them to maintain a fixed path. Of course, by applying external energy, we can remove electrons from its fixed path, but that is a topic for another day. Now, these fixed paths or shells of electrons are named specifically in alphabetical order, starting from KL, MN, and so on. Each shell corresponding to a specific energy level. The closest shell to the nucleus is called the K shell, the next one N shell, and so on. The nucleus, on the other hand, remains positively charged because of the protons, thereby balancing the negative charge of the electrons. The neutrons are also part of the nucleus, but although they are chargeless, they still have mass, so their presence increases the mass of the atom. We will end it here today. There are so much more to discuss on this. So, understanding the fundamental concept we discussed today is of prime importance. If you liked the video and found it helpful, then please subscribe to our channel. More exciting and useful contents are coming. So stay tuned on the Eternal Bright Light channel. We will see you again soon. Take care, goodbye for now.